It might be false advertising, because I know a lot more about how to screw up a Python-based startup. But I thought I'd add the not later on. No one needs 35 minutes of pure negativity. So, okay, how to not screw up a Python-based product startup. That's what we're talking about today. So, day 30 of a 3-month build, 20 developers on a video call. CI/CD pipeline is almost there, someone says, just like week 1. What about basic file upload, I ask? We're integrating PySpark. Silence. A rival team cuts in. How many lines of code have you actually written? Silence. A rival team. Yeah. The developer freezes. Their manager scrambles to deflect. Our CEO frustrated. Why aren't we using Databricks? They do all of this out of the box. The architect starts sharing his screen again. 3 months suddenly feels very short. And in the background, customer success keeps promising features we haven't started. The perfect storm. Okay. So everyone loves good startup advice, like fail fast and always be shipping. Until you're kind of staring at these, very, very kind of hairy problems, and it's hard to know which piece of advice to use. So I've been in kind of 1 or 2 of these meetings, 1 or 2 too many over the years, as a product manager and data scientist. And that kind of inspired me to start thinking about software engineering a lot more. So I spent, I suppose, quite a bit of time over the last few years digging into back-end Python, some DevOps, even some front-end, CSS, Shudder. So I suppose what I want to talk about today is some of the kind of war stories, I suppose, that I've been involved in over the years, where I've seen things go wrong, and hopefully I've learned a few things about what can go right as well. So just a couple of caveats. So one is that it's a B2B focus, because that's what I've worked in. But I'd say some of the lessons should apply to B2C as well. And then the next one is, I'm not an engineering guru, but I do believe that anyone on a project team, whether they're kind of an early career coder, data scientist, data engineer, product developer, can actually impact on technical decisions, if they're handled with care, and can contribute a lot. Right? That's my excuse for interfering with all these things. So yeah, let me share with you what I've learned in the trenches. It's going to help you build your own playbook for shipping Python products that work well. Okay. So let's talk about the MVP phase. So that's that critical kind of 6 months where startups either find their rhythm or they fall apart. So we have our proof of concept at the start, where he kind of does what it says in the tin. It's like, well, okay, this idea could fly. That's great. Then we have our kind of enterprise scale systems later on, where we're working with kind of more well-known patterns. Use the other mic actually. So yeah, working with more well-known patterns. The MVP for me is the piece that is really crucial, because this is kind of where you hit the problems, like the real problems you're trying to solve. You're trying to anticipate issues that you're going to see during that MVP period, and typically I'd say that could last anywhere from kind of 3 to 12 months. So I always think of like MVP, that N of a dozen kind of describes the MVP phase for me. So it could be like a dozen months, it could be a few dozen tables in your database, it could be half a dozen developers or less. That kind of scale is kind of what I'm thinking for MVP. I think it's important to have a sense of that scale, because if you kind of buy into your own marketing and start thinking about a very large number of users too early, and you try and build for that, it's very, very easy to go astray. But at the same time, if you just build for today, you're going to be rebuilding every week, for that 6 or 12 month period. So there's a fine balance to be had there. And the same with customers, that you want to ship fast to them, keep them interested, keep your models tested, but also you want a robust system. You don't want we don't want to alienate your customers. So it's like they're partners rather than guinea pigs, right? So why is this phase so tricky? I think because this is where the real problems are actually solved, that are going to make or break your company. And it's exactly where that chaotic video call was held. So today we'll explore 6 early stage technical decisions that I've seen go wrong, and some ideas for how to approach them better. So 6 ways to screw it up. 1, over-engineering a business problem. No? I haven't seen that one. Data engineering a business problem. Overkilling a technical problem. Microservicing a team problem. Outsourcing DevOps. And the endless ML POC. Right, the POC that never ends, right? So, okay, first one, over-engineering a business problem. Well, business problems often take very predictable shapes. So a common one would be the kind of sequential business process like this. So think something like checking customer status, verifying inventory, processing orders, handling payments. So it might have some branching logic, parameters, maybe some loops. So one classic way to solve this is just basically mirror the business problem in code. I think you see this a lot where data and software teams are embedded into business departments, especially in the banks. And the upside of this is that you have perfect alignment between your code and the business problem. And it makes updates to that code actually an awful lot easier, and conversations with the business an awful lot easier. So there's a lot of plus to it. But the negative, I think, as we probably all know here as kind of Python developers, is that your code can become spaghetti over time. So it's very, very difficult to basically make modifications to that code and to understand the implications of those changes. So the question then becomes, like, how do we maintain business logic clarity while building maintainable code? So in startups, what I often see is teams swinging to the opposite extreme and applying a very abstract kind of design pattern in hopes of creating a more general purpose system, and that's kind of protected against the business messiness. So we might have something like customer status factory, payment strategy pattern, order facade, that kind of thing. And it creates very complex code. And one thing about MVP, I think, is that talent is always very, very scarce. Right? So talent, even if talent isn't scarce in the economy, the talent for your MVP at a particular point in time is likely to be very, very scarce. So you're going to be mixing senior and junior devs quite a lot. So you're freezing out the junior devs quite early then if you go for very abstract patterns. And it can be kind of stressful for everyone. You're not getting the best out of everyone. The second problem with that is that it's much more difficult to communicate a business specification change, because you've got to translate from your procedural logic, your nice kind of procedural flow, into this more abstract kind of, UML diagrams, class diagrams, process diagrams, sequence diagrams, all that stuff. But the thing for me is that after all that effort, if those chosen patterns don't accommodate how your business actually evolves during that 12-month period, well, then it's kind of for nothing, right? So a more business-focused approach, sensible approach, I think that, look, probably a lot of people would do very naturally, is just to zoom out a bit and maybe think of it in terms of, discount engine, inventory manager, payment processor. The code then becomes more organized. You're encapsulating some of the detail, in higher level classes or functions. Now, this kind of thing seems very obvious in theory, but what I've seen in practice is that I've seen teams, I've been one of them, apply very exotic solutions to what's fundamentally here a very straightforward business problem, and then create issues. But we still have a problem. Like, it's not a perfect solution. If within the MVP that the requirements actually change, that logic tree that we saw earlier, the shape could change completely, in which case the shape of your code is going to change completely during that period. So one way to maybe guard against that is to think about it maybe as a business rules engine, for example. So you can basically abstract it into a business rules engine. The nice thing about that is for problems that kind of conform to this kind of pattern, where you kind of say sequential rules with very clear kind of pass, continue, stop, where the state accumulates as you apply rules, and where you just have simple branching based on conditions. Adding a rule to that is very, very simple. You're just adding flat rules into a list as you go. So that upfront cost becomes really, really worth it, over that period. So it's abstract, but it could be suitable for our domain. It wouldn't be suitable, say, for a real-time bidding system or something like that, where it's not a sequential process. There's too many interdependencies between rules in the system. So the key kind of for me is like being problem and domain-led. So choosing abstractions that support the product's natural evolution. So here our abstraction anticipates and accommodates the likely system evolution within the MVP timeframe. So it's not kind of a general abstraction that just kind of adds complexity, but maybe won't give us the value that we need. Okay, data engineering a business problem. So I kind of come from a data science and data engineering background, so I won't claim responsible for a couple of these, but I've certainly done it. So what about when you're processing at a higher scale? So maybe in a batch situation, for example. So I think the standard thing to do is to reach straight away for some kind of a library to do this in a vectorized way. So it could be pandas, for example. The problem here is that even very simple business logic gets completely obscured. It's very, very difficult to read the business logic from the code, because what your framework is really focusing on is data manipulation, and that's what's kind of front and center in the code. The other issue is that if you could change your framework at some stage, you're going to have to do a complete rewrite. If you want to move to PySpark and UDFs or something like that, that's going to be an issue. And so what we've built is potentially more suited to feeding a data warehouse than actually processing orders in a product. So I kind of propose as cleaner ways in this kind of situation. One is, like, instead of forcing our business logic into data operations, we could just wrap it in parallelization. So we could use something like multiprocessing or concurrent.features in the standard library. We could use joblib or Dask. And the kind of beauty of this is that the logic remains untouched. So in this case, it's an embarrassingly parallel problem. The logic just does its thing. The other advantage is we can switch frameworks at any time. We can just put a different wrapper outside of this code and just keep it intact. You could even, if it's kind of more quantitative kind of operations, you could even move it onto GPU with Numba and just basically achieve all of this with just the standard Python library. So this kind of maintains things as transparent and maintainable, and the conversations between the product and the dev teams, they stay focused on business logic and on business logic and not lost in framework complexities. Because during an MVP, your requirements are changing all the time, and so you want to keep those conversations very, very productive, rather than kind of just be talking about the dependencies for a library and all the kind of technical details of it. It's not to say that data tools don't have their place. Obviously, if you're doing some analytics or BI, you're going to reach for pandas, you're going to reach for bipolars or Dask for streaming. You might have a place for PySpark, for example, for scale. But the only thing is, as I've seen time and again, is that data platforms absorb a lot of dev time. So if you want to build a data platform, great. Just don't build one by mistake. Right. You think you've got a product, you've got a data platform instead. The CEO tends not to like that. Look at our shiny data platform. Well, we're into building a product. Okay, overkilling a technical problem. Most B2B solutions are multi-tenant. So have you ever tried refreshing customer data when your schema differs from customers? So the standard or the common problem is that their IDs, customer IDs, for example, are your natural keys. But you have to have your own synthetic keys to keep integrity in your database. You can't really predict if these things are going to change or not. Now, if it's a single table load, it's going to just auto-increment, so it's grand. But generally speaking, we're talking about relational data, so the foreign keys are not going to work. So, for example, in here, if you add a new assignment to a new employee or a new department, that employee or department won't exist yet, so the load will fail. So you're looking at a hierarchical loading problem here. So the parent tables must load before the children. The load order matters. The catch is that each customer's scheme is different, so the order isn't fixed. You can't just hard code it in. Now your first thought might be Airflow or Luigi or something like that to manage it, and that will give you a lot of different features. So managing dependencies, doing orchestration of all this, retries, monitoring, and it is a DAG. It is a DAG, like it's a directed acyclic graph. So it's a natural fit. But one of the things I find in MVPs is the pipelines, the data pipelines are often actually very, very simple. So it could just be a CSV upload, it could be a dump from an API, something like that. So you've maybe a single source or a couple of sources, and the target is generally a single target. You're putting data into a database. So when you start putting an ETL framework around this, you're probably only using a very, very small percentage of that framework feature. And then you have the heaviness of maintaining, say, an Airflow web server, scheduler, database config, all that stuff. So either tool would add hours of setup time, ongoing maintenance, and new failure modes, all to solve what's essentially a simple dependency ordering problem. Right. So you could hard code the load order, but again, like that would just break as the customer schema breaks, because again, you're in MVP land, things are changing all the time. So to keep it dynamic, like enter graph theory. So what you can do is just pull the schema of tables at runtime, build a dependency graph, and then use a classic CS algorithm, topological sort, to basically get your load order. It's like that comes to really a few dozen lines of Python code. Like it's not a crazy amount. If you want to be really lazy about it, you could just keep trying. Basically do a double loop, and some tables will load in the first pass, and basically keep going. It's quadratic time, which people in the textbooks don't really like. But if n is a dozen tables in your database, or a couple of hundred tables in your database, that's basically nothing. So brute force actually works quite well in this situation. The only thing is that your log is going to be a mess with all the retries, and it's going to be very hard to debug it. So for me, like a couple of dozen lines, topological sort is a nice kind of elegant kind of midway solution here. The one solution I don't recommend is just getting rid of synthetic keys. So I did see this actually in one team I worked with did implement this. But it's kind of like that Einstein quote of like, make things as simple as possible but no simpler. Without keys, you're completely unprotected from changes in the data, and you're going to end up with broken relationships and integrity problems in the data and all sorts of things. It's difficult to deal with. So yeah, in this case, I found that like a carefully crafted kind of algorithmic approach vastly outperforms a framework solution in terms of functionality and also in like terms of the total cost of ownership of the solution. Basically, it's a small module in your code. Okay, microservicing a team problem. This is one of my favorites actually, because yeah, this I might have done this one. The temptation is real when collaboration gets messy, and it always does. Breaking up the code base into microservices seems like a perfect solution. So what you're doing is you're handing out discrete tasks. Everyone can just work, get their work done, no messing, no mega merge conflicts, no task dependencies. It worked for Amazon, so why wouldn't it work for my MVP? Well, okay, obviously there's a few differences. At MVP scale, this is not really solving a technical problem. So what you're kind of doing here, I think, is you're trying to solve a human problem with a technical solution. And here's what actually happens, in my experience, when you force microservices too early. Devs start communicating through API contracts. And I'd liken that to like basically being in separate rooms and talking through keyholes. Right? Communication is rubbish. So what you've done is you've transformed endless discussions about merge conflicts, but about features that actually matter in your product, into endless discussions about JSON schemas and API versions. So instead of debating important architectural questions, you're arguing about whether that field should be camel case or not. All right, so we're no longer focusing on the right things for an MVP. So here's what I learned works better, again in my experience, just to go the other way entirely and to make everyone full stack. Like database up to UI, even CSS. Because I think like the key thing in an MVP is to understand the product holistically. I think it's necessary, but it's also desirable. It also has led me towards more batteries included web frameworks over the last couple of years. So I love Fast API, I love Flask, but for an MVP, when you're actually doing a full, it has to be a full solution with all the different things you normally need. I'm starting to look at Django, even Rails, Ruby on Rails. And I want to emphasize that because I don't want the answer to how not to screw up a Python start to be don't use Python. That probably wouldn't be the message I want to come away with today. Just kind of like the separation of concerns of those kind of micro frameworks is great, but for MVP, I think there's a place for frameworks, and I think that maybe is a really good place for a framework if you're going to use a framework, as opposed to say maybe so much on your data side or in other places. So what you're kind of doing here is, I think by using kind of more fleshed out frameworks is to solve old problems is you're kind of free to focus on your IP, focus on actually what matters about your business problem. So save the microservices where they really matter. Like that could be, say, for a transformer model that needs its own scaling rules and deployment cycle. So there's technical reasons to stand up a microservice. Okay, outsourcing DevOps can be costly. Remember migrations that worked on someone's machine but failed in prod? Ever happened to anyone? No? Okay. Did it ever not happen to anyone? Maybe that's the question. Or the solution architect who gets excited about using Kubernetes for your 2 or 3 container application. Right? I've been all these people, by the way. The way I think the kind of fundamental issue here is that DevOps isn't really a separate service to consume. I think the idea of DevOps was we were combining development and ops, but then, we kind of wanted to continue doing our coding and we pushed it away. And then it really became ops again. And I think that's a problem. So for me, DevOps is kind of how we deliver software. So at an MVP stage, I propose that every developer needs to understand how their code reaches production, like gets all the way into production. And every architect needs to justify complexity with real problems, not future ones. So infrastructure decisions, they're too important to outsource or delegate upwards. The solution I find works well is basically make it all code, day one, like just from day one. So, have GitHub Actions or Ansible or whatever it is, doing your deployment, doing your CI/CD, use infrastructure as code, like say with CDK and Amazon or Terraform, whatever it is, because generally speaking, we're a team of coders. So if we turn deployment and infrastructure into code, it becomes under our control. It's a lot easier to work with. And if backend developers can learn CSS, they're happy enough with YAML, right? Because basically that's all CI/CD is, just a bunch of YAMLs, right? The great thing about these things is, I kind of let myself be talked out of CI/CD a few times. It was like, over engineering, we don't need it, it's small. But I think the word over engineering can be, I've used it here, I don't like it, because I think the problem with the word over engineering is that any time a more complex solution is suitable, that's kind of, it's over engineering, and the discussion gets lost. I think it's always about cost and benefit. And for me, programmatically doing your infrastructure on day one of any project, beyond the simplest POC and Streamlit, it's a few hours. It's not going to change that much, like over the 6 to 12 months of your project. You're just going to get so much out of it. And from a learning perspective, you learn it once. Like Docker hasn't changed in 10 years. Reverse proxies I don't think have changed in 20 years, right? So you learn this stuff. I don't think teams should shy away from it. It's not hard. And just kind of an addendum there. So Page and Brin didn't just figure out PageRank, they also cracked distributed computing and commodity hardware at the same time. So you just own your own platform is the lesson I learned there. Okay, last one. The endless ML POC. So ML in products is computing for uncertainty. And so you're already in an uncertain world of startups, so it's basically uncertainty squared. Your trained test, your cross-validation is only a clue as to how performant your models actually are. You only get the data once you deploy it to customers. That's the only time you actually know if your model actually works. It's real data, real customers, real situations. There's no point asking someone to evaluate a model prior to that. They won't know. So the analogy I like here is a policeman sees a drunk man searching for something under a streetlight, asks what the drunk has lost. He says he's lost his keys, and they both continue looking under the streetlight together. After a few minutes, the policeman asks if he's sure he lost them here, and the drunk replies, no, unless he lost them in the park. The policeman asks, why is he searching here? And the drunk replies, this is where the light is. So that's what happens in MVPs all the time. So we spend weeks tuning our model, improving the RMSE, but it turns out the client only really cares about the variance of the error, for example. So we stay in the data science lab where the light is better. Right? But deploying models is difficult. The Python ML stack is built for research, if that. PyTorch is only, I think, moderately better than TensorFlow is for this. Onyx is great, but there's just no silver bullets. I spent 3 days once chasing down a model in a transformer deployment, and it turns out that I was passing named arguments to a function that accepted them, but didn't treat them as named arguments. So the order actually mattered. So it was bugged deep into the PyTorch, just 3 days. So we're navigating a maze of tooling quirks. So I think just the best thing to do is kind of meet those problems head on and just deploy, deploy. I often go back to the old crisp DM diagram of the ML lifecycle. I think it never goes old. But I'd add an arrow here because I don't think you get proper evaluation until you actually deploy. Right? So when you deploy, then you start getting that nice kind of flywheel. You can't discover these things in advance. I'll just give you one example of when I was working on forecasting applications. We did obsess over the RMSE and the MAPE and everything else and which error message to use. It turned out the only thing the users cared about was the variance of the error. And if you think about it, that's very common in forecasting, because if you have an empty ice cream freezer on a hot day, right, on the biggest day of your year, say in a retail shop, that single error is the one that's going to cost you and going to cost somebody's job. You don't care about a 5% difference, 10% difference throughout the year. The average error we obsess about as data scientists because we're in the lab. We're not really looking at how these things are used, under stress. So yeah, again, your customers or your partners, they're not guinea pigs, but they will actually uncover all these things for you and tell you what's important. And if it turns out in that case that variance of the error is important, that's a complete rebuild all the way back through your stack, because most forecasting models, they're very hard to tune for that. It's not differentiable if it's a machine learning thing. So your product is actually under, you're going to move to another phase of your product based on that single bit of feedback. All right. Whereas you kind of want to know that pretty early in the cycle. So I would say this is the place where the advice to fail fast, I find that to be most applicable. Always be shipping your models, and that'll manage the uncertainty. Okay, so I said I wouldn't tell you what to do, but for anyone who just wants me to tell them what to do, which that'd be very unwise, but if you did, for whatever reason, here's what you should do and not do. I won't read them all out, but have a look if you're so inclined. This is what I would propose. Yeah, and that's it, right? But these are specific learnings at a point of time. These things change, and you'll have your own kind of solutions that you're going to thinking about. So maybe what I'll just close with is what I would say are maybe some more general principles that might stand the test of time a bit longer. And one is kind of just to be cognizant of your building blocks. So like new algorithms, basically. It could be your business rules engine, it could be your ML model, it could be a new CS algo even. That's your IP. That's what you should be focusing on. Secondly is custom patterns, like the lightweight hierarchical loader or whatever thing you find very handy and useful in your application. That gets you agility as an MVP. And then just frameworks for everything else. And what they're really doing is buying you time to work on the first two. And then in terms of priority, I would focus on in that order. Versatile teams, again, I am really moving towards the idea of a few full stack developers over a dozen specialists. I think actually just works an awful lot better, for MVP phase. The solution is rarely under the streetlight, so, don't spend time doing the easy things. And I'll just end with a quote from a friend of mine. It's actually from Mark Twain, I think. Eat the frog. Basically, do the unpleasant, difficult thing first that you're going to have to do. Get it out of the way. Instead of noodling, kind of create the ultimate data platform that nobody really asked for in the first place. So what does success look like? Well, dream status updates. Users love the forecasting engine. We got to change maybe we've got to change the cost function slightly in line with their expectations, whatever it is. We're moving some workload to DigitalOcean next week. Yeah, I'll take that one. I need a break from CSS, you know. So your team is confident, your tools serve you, and the product just keeps evolving. So yeah, just thanks to people I worked with over the last few years who helped kind of help me learn these lessons in discussion and you know, in the middle of the fire sometimes. I think I see Sean there today, and Carshall's around. And that's it. It is time. I hope there is. Sorry, it went on a bit too long. Really appreciate any questions, comments, or objections to the whole thing.
Can you touch a bit more on parsimony and as simple as you can, but no simpler?
Yeah, I just start with code for simple things, move to libraries, frameworks. I just kind of do it in ascending order rather than start from the biggest chunk down, because I think, like, to keep control, you know, like I came in from data science, so I was much more about libraries initially. I'd always reach for pandas, I'd reach for this, I'd reach for that. So I kind of late in my career discovered algorithmic thinking. Whereas I think people coming out of software engineering probably have a, you know, a good sense of that. And I think, like, to keep your algorithmic thinking, you'll find some really cool solutions. You know, that it's like you get the building blocks that you can shape them, you know, whereas the other ones are the big Lego blocks that you can't really build anything novel, I think, in that way of thinking. So I just start from the algorithms up rather than kind of come the other way down. Yeah.
Thank you. Hi, great talk. Thank you for that. I'm going to maybe try to challenge something a bit, just as a food for thought. One of the things that I see as being mentioned as a benefit of infrastructure as a code is that it's provider independent. And from experience, it doesn't seem to translate into reality. For instance, you showed a piece of code of AWS CDK, which is already not provider independent. Terraform could be. Yeah. Have you ever seen situations where somebody actually benefited of that? Going, okay, I want to change cloud setup. Here I have my Terraform files, and it works almost perfectly.
Yeah, so I think the standard for me of kind of measuring the success of it is versus not using it, you know. So if you don't use it and you're going around consoles and stuff and you make changes throughout your project, it's just near impossible to, you know, and even if you stay in the same cloud, to stand up a dev prod and separate environments becomes a nightmare. So I think even if you're not moving cloud, it's very important. But for moving cloud, if you think of it, you have one script. Like basically you have a script which just is saying, okay, the syntax might be slightly different, but it's saying, well, my elastic IP is this, my SSH host is this. It's actually not that hard to translate that into a different language. So I think you're kind of going from, you know, potentially days and weeks of messing down to, like, you know, maybe a couple of hours. So I'm not too worried about the exact fit. You know, it's just, can you, yeah.
Thank you so much.